So I'm here with the BT28, the latest ThermoStream from Intest Thermal. As the name suggests, minus 28C all the way up to 225C. And there are other systems in the family that go much broader temperature ranges as well. One of the nice things about this benchtop system is it's really quiet, minus 28 to 225C at a flow rate of up to 14 CFM. And that flow rate is available regardless of the temperature. Okay, so minus 28C at 14 CFM if you need it. One of the many advantages of this kind of test setup is that you can test your unit under test on the bench. So in this case, we have our unit under test here, and of course, in a normal lab environment, you'd have other ancillary test equipment, power supplies, logic analyzers, etc. And you can do it all on your test bench, as opposed to trying to locate this into some kind of a chamber. There are two ways that this system can be used. One is in what we call air mode, where all we're defining is the temperature of the air coming out of the nozzle into the enclosure beneath it. The second way, and of course this is in many cases more important to the user, to the engineer, is when he needs to know what the case temperature is as opposed to the air around the device. And so we have a second mode of operation which is called DUT control. So if I want to use the system in DUT control, the first thing is I take a secondary thermocouple, in this case a T-type, which I now attach to the unit under test. Okay. And on the screen, the user interface, now I see two temperatures being reported. One is the air temperature, and the other is the DUT temperature. And the system, through its control algorithms and the PID control loop, drives the air temperature to achieve the required DUT temperature. So here we are in DUT mode. You'll see that the DUT temperature is around minus 5C, and the air temperature is a little bit colder in order to maintain that temperature. And if I now want to drive the temperature hot to say 100C, I can select that set point, and now you'll see that we've got, the heating is going on. We're at 45% heating. The air temperature here is rising, and the DUT temperature is following somewhat delayed behind it. So the air temperature is rising, 50C, DUT temperature, a few degrees below it, as we're driving towards the set point of plus 100. Let's select the graph mode here. You can now see that there are three traces being on the plot. The red line is the actual set point. The green line is the air temperature, and the yellow line is the DUT temperature. And again, you can see the offset between the green and the yellow as we're driving to the set point of plus 100C. If I return back to the operator mode, you'll see now there's that delta. We've got about 130C as we're coming into the set point here of 97 and toward 100. So now, of course, we're now nice and solid at 100C. You can see that the air temperature is elevated by about 13 degrees in order to maintain that case temperature of the unit under test. And if we think about what DUT control offers us, there's some really good advantages. First of all, of course, we're now confident that the case is at 100C in this case, as opposed to the air around it. But the second thing is that we're now able to take a significant advantage of the horsepower that the ThermoStream offers, right? We're able to drive to temperature extremes beyond the set point in order to get to the set point or the case temperature much faster than you ordinarily would. And so that reduces the amount of dwell time and therefore improves your overall test time. Test time to get to temperature in some cases is really important. And one thing to note, of course, is that there are software limits that you can put on the system so that you limit how hot or how cold the ThermoStream will go in order to achieve that case temperature that you're looking for.